Alright, so we're going to start out with some different types of trig sub problems. And the first type we're going to do is going to be ones that involve e to the x. So we've got, for this one, dx over e to the x square root of e to the 2x minus 9. So it looks a little bit different. You guys may be able to recognize it as one that requires trig sub because this is kind of like a u and a u squared minus 9. But it's not just u and a u squared minus 9. So let's do a u substitution first. Let's let u equal to e to the x. Therefore, du equals to e to the x dx. But I'm going to solve for dx here. Dx equals to du over e to the x, which is du over u. So we want to be careful when we make this substitution in here for our dx. So the dx I'm going to write on the outside. This is du over u. And I have e to the x, which is our u, square root of e to the 2x, which is u squared, minus 9. So notice I really have a u squared square root of u squared minus 9 on the bottom. So if you weren't careful, you could have missed that extra u, and it does, of course, make a difference. So this is going to be a type that involves an x squared minus a squared. So if you remember from yesterday, that means that we need to do a substitution involving secants. U equal to 3 secant theta, and du equals to 3 secant theta tangent theta d theta. Now I caution you guys, make sure you don't use x in here. I know you guys like to use x, but remember our original problem involved x's, and if you start putting dx's in there, you're going to get confused because you think you have already back substituted. Okay? So we are going to do our trig sub now. So our numerator is going to become 3 secant theta tan theta d theta all over 9 secant squared theta square root of 9 secant squared theta minus 9. Okay, we can factor out the 9 underneath our radical, and secant squared theta minus 1 equals 2. Do you guys remember? That's going to equal our tangent squared theta. I can actually simplify a few other things here. I'm going to have tangent theta d theta up here on the top. I have a 3 secant theta, and my radical will give me a 3 tangent theta. Okay, because remember there was a square root here, and so we just have a 3 tan theta left over. So continue to simplify. We have 1 over 9 integral of cosine theta, which is actually nice and easy, which is 1 over 9 sine theta plus. So we have to back substitute, and there's a couple things here. So our original trig sub here was u equal to 3 secant theta, but I'm going to also back substitute my e to the x. E to the x was our u, so instead I'm going to use secant theta equals e to the x over 3. So my triangle with the secant has this being hypotenuse over adjacent. So our missing side, using the Pythagorean theorem, is e to the 2x minus 9 under the radical. So when we back substitute, I have 1/9 sine of theta, which is square root of e to the 2x minus 9 all over e to the x plus our constant c. So a little bit trickier, a lot more things to do on this one. This next type is going to be ones involving completing the square. So we have dx over x squared plus 4x plus 5. Okay, I know some of you guys are going to look at this and think that doesn't even look like it's going to need trig sub, but the directions in your homework, they're going to say to complete the square, so kind of keep that in mind. Okay, Now completing the square. What we're going to complete the square on is this part right here. If you want to do it on the side and then plug it back in, that would be fine. Do you guys remember how to complete the square? We would want, instead of the plus 5, we would like to have a plus 4 instead. So I'm going to separate and break off a 4 from the 5 that's already there. That would leave me with x plus 2 quantity squared plus 1. This is what I mean by completing the square. So I have x plus 2 quantity squared plus 1. Now I know this particular problem doesn't have a square root over it, but it very well could have. This is going to match up with the type that involves a tangent. So it's a little bit different because I have an x plus 2. So our usual substitution was x equals to a tangent theta. But my x really isn't just an x, it's an x plus 2. So I'm going to let x plus 2 equals to a tangent theta. And in this case, my a is 1. So when I take the derivative, I just get dx equals to secant squared theta d theta. Notice how the plus 2 just goes away and it doesn't become part of my trig substitution anyways. So let's continue on with our substitution. I'll put secant squared theta d theta up in my numerator. And then I have x plus 2 quantity squared, so that means I have a tangent squared theta plus 1. And what does tangent squared theta plus 1 equal to? It equals to a secant squared theta. So that's going to completely cancel out. So all I have left now is the integral of d theta, which is a theta plus our constant. Remember, we have to put back our triangle, or draw our triangle, and put back our x's into there. Our original substitution was tangent theta equals to x plus 2. So that means opposite over the adjacent is our tangent value. And our missing side is going to be the square root of 1 minus x plus 2 quantity squared. Oh, well, actually, we didn't even actually need the triangle in this case, because our integral resulted in a theta. So I really just need arctan, or inverse tan, of x plus 2 plus c. Well, just in case there had been something else other than just an angle theta, you would have the triangle already done. Okay, I'm going to do a couple more with this completing the square, because I know that this is actually quite challenging for some of you guys. So we'll do the integral of dx over the square root of 1 plus 4x minus x squared. Okay, so on the side, I'm going to do the completing the square. So 1 plus 4x minus x squared. I'm going to rewrite this and make it 1 minus the quantity x squared minus 4x, and then I want to complete the square. Alright, so it should be kind of easy to complete the square. It's going to take a 4, but I have changed my problem. I actually added in a 4 inside the parentheses, so I have to balance it by actually adding a 4 on the outside, because I have the negative on outside of my parentheses here. So this really is 5 minus the quantity x minus 2 quantity squared. So I'm going to rewrite my original integral, and I haven't done any substitution or anything. I have just chosen to rewrite my expression. I have 5 minus the quantity x minus 2 squared. Now this fits the type of a squared minus x squared, which means I need to substitute with a sign. So I'm going to let x minus 2, so all of this, equal to, in this case, a squared is 5, so it's actually a square root of 5 sine theta. So a little bit trickier. I hope you guys can follow. So dx will equal to a square root of 5 cosine theta d theta. Now I'm going to substitute. So square root of 5 cosine theta d theta all over square root of 5 minus, now we're going to substitute in our x minus 2, which is all of this, and square it. So what goes underneath here? When we square x minus 2, we get 5 sine squared theta. That's our trig sub. So simplifying everything, I have square root of 5 cosine theta d theta over, I can factor out the radical 5. I have a 1 minus sine squared left over, which is a cosine theta. And just like our previous problem, actually, everything cancels out nicely. I don't expect that to always happen. This is going to give us a theta plus c. So since I know that x, my original substitution, was x minus 2 equals radical 5 sine theta equals x minus 2 over radical 5, I can go ahead and just use arcsine of x minus 2 over 5 plus c as my final answer. Was that any better? Hopefully a little bit easier. I'm going to do one more with completing the square. So if you think you've got this down pat, then maybe you don't need to watch this one. But if you want some extra practice, I really strongly suggest you watch this one. It's another completing the square. 2x minus x squared in our denominator. Okay, so I'm going to complete the square. Again, I'm going to complete the square over on the side. When we complete the square, we don't want a number in front of our x squared, so that's why I'm factoring out the negative, because it's like a negative 1. So I really have negative the quantity x squared minus 2x. Okay, what number completes the square? A 1. But I'm really subtracting 1 because of this negative sign on the outside, so I need to balance it by adding 1. I'm going to put that 1 in the front, so I really have 1 minus x minus 1 quantity squared. That's going to go in here underneath my radical. So all this work that I've done so far is really just preparing my equation, or my integrand, for a trig substitution. Alright, now this one again involves an a squared minus x squared, so we're going to use a sign for our substitution again. So we're going to let x minus 1 equals to sine theta, so dx equals to cosine theta d theta. So our numerator is sine theta, dx is a cosine theta d theta, and our denominator has a radical 1 minus sine squared theta. Okay, so 1 minus sine squared theta is a cosine squared. We take the square root of it. It's going to cancel with our cosine up at the top. Works out kind of nice in this case. So what's the integral of a sine theta? It's a negative cosine theta plus c. Hopefully you guys remembered the negative part. We have to back substitute with our triangle, which says that sine theta is x over 1. So opposite over hypotenuse. And our adjacent side is square root of 1 minus x minus 1 quantity squared. Do you recognize that? That's what we completed the square with. So that actually equals to the square root of 2x minus x squared, part of our original problem. So when I write out negative cosine theta, it's actually negative radical 2x minus x squared plus c. Okay, so you're going to need to try your best on these different types of trig sub problems tomorrow.